and its matrix. Or else even we can call it as a matrix of linear transformation also we'll call it. Okay. So and is not there, comma, it's matrices. Okay. So linear transformation, it's matrices. So this is the block 2. In this unit 4 is about the linear transformation we have. Okay, linear transformation. So this is the important one and this is a somewhat a problematic one. So such that instead of the theorems, even you can do the problems regarding of the linear transformation. Okay. So I have told that linear transformation is generally just, it is as same as we'll find the mapping, no, for a function mapping. So linear transformation means this transformation we can call it as a function or we call it as a mapping. Okay. So for the function, we'll do the mapping, no? So usually in the functions we have learned in the intermediate and even lower classes. That is a function will represent with f and it will be mapping from set A to set B. Okay. So this is the domain and this is the codomain. So how we have seen the function which is mapping from A to B, in which whatever the A set is called as a domain set and B set is called as the codomain. And with the help of the mapping, this whole representation we can do like this. Okay, this is set A and this is set B. This is the function between A and B. So A, you can take any elements. So like this 1, 2, 3, 4. If you take here A, B, C, D, like these elements. So elements in set A and elements in set B. So when you do the mapping like this, okay. So mapping like this, if you do, okay. So this is called as domain. And this is called as codomain. Okay. So even this is a function. How we can tell this is a function? You have seen even in the questions that whether the given set is a function or not, given the relation is a function or not. So when you will tell that it is a function or not means each and every element of the domain. Here how many elements are? 1, 2, 3, 4. 4 elements are there in the domain. So each and every element of the domain should have some image in the B, that is in set B. It should have compulsory image in set B such that then only we call it as a function. Okay. So if any element is left without any mapping, then we will not call it as a function. Okay. Compulsory, the condition to become a relation as a function is that it should, whatever the elements are there in the domain, they should have compulsory image in the codomain. Okay. So then even so if you have the elements in A, only one image in codomain, then we call it as a one-to-one function. Okay, one-to-one function. And almost if domain is equals to codomain, so means all the elements, wherever the elements are there in set A and set B, then they are equal. So then we call it as a one-to-one function. So if only one image is there, then we call it as a single image. So if you think you have one more image like this, so 4 is having even 2, so then it is not one-to-one function. It is a function, but it is not one-to-one function. So this element should have only one image. Okay. So then we call it as a one-to-one function. Okay. So even we have the concept of range. Okay. So this range means whatever the elements which are present in set B, if they have the pre-image in set A, then these elements are called as a range. Okay. So range will be, So if you take out this one, then you will understand the concept of range. Okay, this is only having here what happened in the codomain, one element is left which is not having any sort of mapping with the set A elements. Okay, this is left without any mapping. So here codomain is equals to, so what are the elements? A comma, B comma, C comma, D comma, E. Okay, but what will be range? Range is, so whichever elements will have the image, those elements are only called as a range. Okay. So that means only A comma, B comma, C comma, D. So D, E is not having any image. So it will not come under the range set. Domain set will be or whatever the elements that are present in set B, those are called as codomain. Whichever elements you are having the images, those are called as a range. So that is the difference between range and codomain. Okay. So in some cases, if E is not there, okay, if E is not there and all the elements are having the mapping, so then codomain and range both are equal. Okay. So here also if we'll take out E, what will happen? A, B, C, D and A, B, C, D. So whatever the elements are there here, they have the pre-image in set A. So then codomain is equals to range. Okay. If codomain is equals to range, then it is, we can call it as a onto function. Okay. Onto function. One-to-one function means, and one condition will be there. Here, no element should be left without having any mapping. Compulsory set A should have the images in set B. Okay. So then we will call it as a one-to-one function and it should have compulsory only one mapping, only one image in the set B. So when we call onto function means if you here E was there no before. So then it is not called as a onto function. Why? Because this is not having the image here, no? In onto function, compulsory whatever the elements are there in set B, they should have the images in set A. Okay. So just a little bit will be there, confusion here. So compulsory set A, all the elements should have the images in set B. Then first we call it as a function. If they have only single image, then we call it as a one-to-one function. Okay. Even if here the element is there, then also we call it as a one-to-one function. Why? Because only one image is there. The thing is compulsory, it should have one image. Okay. So then we call it as a one-to-one function. And when we call onto function means sometimes in some cases one-to-one function and onto function both will be same also. Okay. One-to-one function will become even onto function. Why? Because if your not element is there, what will happen? This is one-to-one function and even this is onto function. But if we have here this one more element here, this is not onto function, but this is one-to-one function. Okay. So onto function, the condition is here the element should not be left with the images. Compulsory, it should have some image in the set A. Okay. So this, if you remember the concept of the homomorphism of the groups and also homomorphism of the rings, there too, there is a fundamental theorem is there, no? Fundamental theorem of homomorphism of groups and rings. There we will find the first starting. We will show that F is a well-defined, F is 1, 1, F is onto. Okay. So whenever we show F is 1, 1 and onto, so if you know these conditions, then you can easily solve that homomorphism of the groups. Okay. Even this linear transformation, whatever the transformation is there, that we can linear function or we can tell linear mapping, or else linear transformation, generally it is also known as vector space homomorphism. Okay. Even we can call it as vector space homomorphism. Okay. So like this, so you should know what is the concept of domain, what is codomain and what is range. And when we call it as a function, that is onto function, when we call it as a one-to-one function. Okay. So by this we can solve the problems and also we can solve the even theorems also. Okay. Some theorems are there regarding of the one-to-one function and onto function. So combination of one-to-one and also onto function, we call it as a bijective function. Okay. This is also important. So in theorem, one theorem is there. There you will call it as a, whenever it is a one-to and on-to function, that is a bijective function, then the transformation, linear transformation, we can find the linear transformation inverse. That is the inverse linear transformation is also there. So for that, the condition is that compulsory the linear transformation should be 1, 1 and onto. That means if it is a bijective function, then we can find the inverse of the linear transformation. Okay. So even I have told the definition of the linear transformation. So two definitions are there. So for solving the problems, you can use any two, from that anyone you can choose and you can solve the problems. So I have told that compulsory one question in for the 5 marks, you will get for showing that given whatever the transformation is there, the transformation is linear transformation or not. So 5 marks question you will get. Even in some case, they may ask for 10 marks question also. Two problems will be given, 5 marks. Then you have to show that the given transformation is linear transformation. Okay. So here for the function will represent function A to B, no? But in transformation will represent it as, instead of F, will represent it as T. So T is mapping from V to W. Okay, capital W. This is the, similarly, this is domain. This is codomain. Okay. So how the mapping, we have seen the mapping of F from A to B. Similarly, from T, V to W. And V comma W are two vector spaces. Okay. Or vector spaces over the same field F. Capital F. Okay. So these two are the vector spaces. How here these two are the sets. Similarly, V comma W are the two vector spaces over the same field F. Okay. So T is the transformation from that. So we can tell the mapping will be like this here. This is V and this is W. And here vectors will be V1, V2, V3. And here the vectors will be U1, U2, U3. Okay. Like this you can take any. And this is the transformation between V to W. Okay. Or V to U, capital U, you can take, or else you can take V comma W also. Okay. So how the set will be, the images will be like this. F of V1 is equals to, what is the image of V1? It is U1. And the image of F of V2 is equals to, it is U3. Next, F of V3 is equals to U2. Or else we can write T of U1 equals to, why? Because here the function is T, no? So T of V1 equals to U1, T of V3 equals to V2. So this is the representation. Similarly, how the mapping is there, same like that only we have for the linear transformation also. But here the thing are, these are the vectors. So whatever V1, V2, V3, U1, U2, U3 are there, those are vectors. Okay. And the definition, two definitions I have told, no. So on that, even we see today the problems regarding of the linear transformation. Okay. So these definitions are important for solving the theorems and also for solving the problems. So first one is, if F is mapping from V to W, is called a linear transformation. So in shortcut, we can write LT. Okay. It is a linear transformation if first condition is F of alpha plus beta also you can take, or U plus V, anything. Okay. Or else F of alpha plus beta also, any vectors. Okay. U plus V is equals to plus f of v, or f of alpha plus f of beta. This is the first condition. Okay, that is, this is the vector addition. Okay, starting vector space, I have told that two vectors, when you add them and whatever the addition symbol is there in between of the two vectors, then we call it as a vector addition. Okay, second condition is, that is a scalar multiplication. So f of a into u, or you can take a into alpha. Okay, so a into alpha is a you take outside, then into f of u. Here a into f of alpha. Okay, this is vector addition. Okay, and this is scalar multiplication. This is scalar and this is vector. Okay, I have shown in the vector space definition. So what is vector addition and what is scalar multiplication? Okay, so this is the one definition of the linear transformation. If these two conditions are satisfied, then any given transformation is a linear transformation. Okay, and second one is just combining these two. So combining 1 and 2, you will get the formula it as or. So another definition is f of a into alpha plus b into beta is equals to a into f of alpha plus b into f of beta. Okay, so in some problems we'll use this formula of the linear transformation, or in some we can use any first and second. Okay, so to show any problem that it is a linear transformation or not, if first condition, if you'll see, if you are getting like whatever the left hand side is there, if you get the same value as the right hand side, then it is a linear transformation. If you are getting both the values as different, so here only you can stop and you can tell that it is not a linear transformation. No need of going the second condition. Okay, so for some problems, with the help of this one, you can show that the given transformation is a linear transformation. Okay, so in some case we can use this, and in some cases we can use this one directly. This is only single formula. Here means two conditions it has to satisfy. Okay, so if you see here, this is how you got this definition, means combining first and second one. See, first one is what? F of u plus v. This is same as u plus v. That is, this whole thing is u and this whole thing is v. Now what we have? F of u plus v. So how it is defined? F of u plus f of v. That means f of a alpha plus f of b beta. Okay. Now how these two are in the second condition, f of au, f of a alpha, next f of b beta. Means scalar multiplication. How you are splitting that? When you split this, you will get this one. Okay. So combining of these two definitions, you are getting this one. So it is not different and it is not different. Both are same. Just combining these two conditions, you are getting this definition. Okay. So main thing, you have to remember these three in solving the problems. So now we'll see one problem regarding of the linear transformation. So if you know the concept of how to solve this problem, then means you will score 5 marks in the section A. So from the textbook, one exercise problem is there. That only I am telling. See T. So T is mapping from R2 to R3. Defined by, here the definition is given as T, A comma B is equals to A plus 2B and 3A plus B. Is T a linear transformation? Okay, this is the problem. So here, whatever the T it is there, it is mapping from R2 to R3. Okay, these R2 and R3 are the elements of the basis. These are the basis. Okay. So the elements here R2 is there, no? R2 or you can call or R square or anything. So generally we call it as R2. So R2 means the elements will be in the form of like this. Two elements will be there. Here 2 is there, no? Power means A comma B. And R3 means 3 elements will be there. So here you can take A comma B comma C. 3 elements. So that's why here wherever the transformation is there, that is defined as T A comma B. It is from this one. And R3 means it is from this one. Okay, 3 elements. 1, 2, 3 elements are from R3. R2 means 2 elements. Okay, so you have to show that whether this whatever the transformation which is mapped from R2 to R3 defined as, how the transformation is defined, it is defined as T A comma B equals to A plus 2B, 3A plus B. Okay, so whether it is forming a linear transformation or not. Okay, so this you can do in the two ways, whether you can use the, that is the first definition is there, no? That one, or else directly you can take the second definition. Okay, so with the help of the second definition, we'll do this transformation. So here, before going into that, so how it is defined means T A comma B is there, and here A comma means this is the element only with A, and next one it is A plus 2B. Next we have 3A plus B. Okay, so for this you have to assume that here A comma B values. A values are A1 comma B1 and B values are B1 comma B2. Okay, so with the help of that, if you substitute here in this, then we'll get the relation. And if both, our formula is this one is f of A into alpha plus B into beta is equals to A into f of alpha plus B into f of beta. This we have to show. So first you have to take the left hand side, and if whether it is equals to right hand side means both, if they are, you are equating this one. LHS, if you are equating to RHS, then the given transformation is linear transformation. If you are unable to equate these two, then the whatever the transformation is there, that is not a linear transformation. Okay, so for that, first you take that. So if we can, this is the function f, no? So here t is defined. So with the help of t also you can do, that is t LA plus MB. Okay, here A comma B are there, no? If in the problem alpha comma beta are given means you can use directly, you can write like this. But here A comma B are there. So this is A and this is B of this transformation, and this L and M are the here scalars. Okay, so that is instead of this A and B, these are A and B. So this instead of here whatever given in the question, if X comma Y is given in the question, okay, then you can write that is X into alpha plus Y into beta. Here already A comma B are there. So that's why we are using that same A comma B. Instead of A and B, we are using L and M. Okay, this whatever the alpha is there, this is A, and this whatever beta is there, this is B, given in the question. Okay, and L and M are A and B scalars. Okay, these two are the vectors and these two are the scalars. Okay, so if you define this, what you will get? L is alpha, alpha is A, no? So A, whatever L is there, that you will get outside, and T of A plus here M into T of B. Okay, so this we have to prove this is equals to this one. For that, let, so here A comma B is there. If in the question alpha comma beta or in the question X comma Y is given means, you can take here A1 comma B1 comma A2 comma B2 belongs to R2. Here only two elements, no? So here this A comma B is defined as A1 comma B1, A2 comma B2, which belongs to R2. Okay, so that is, we can write it as this, whatever A is there, this A is equals to A1 comma B1 and B is equals to A2 comma B2. Okay, and here T of A comma B T of A comma B is equals to, it is defined as A comma A plus 2B comma 3A plus B. Okay. Now, this one, no? This one is T of LA plus MB is equals to T of this L into what is A? A is defined as A1, B1. That is A1 comma B1 plus M into what is B? B is defined as A2 comma B2. Okay. Now this is in the form of vector addition. Okay. So it is equals to T. First you multiply this L with these two elements. That is, it will be L into A1 comma L into B1 plus M into A2 comma M into B2. Okay. Now you add the first terms. These two first terms. Then we'll get it as T LA1 plus MA2. Okay. So adding these first two terms. So you will get it as LA1 plus MA2 comma. Next this term and this term. That is LB1 plus MB2. Okay. Now see here, after first you have multiplied the terms with L and M. After multiplication in the vectors, whenever it is in the form of the coordinate form, this is the coordinate form. Now we'll write 1 comma 0 plus 0 comma 1. In vectors, what we'll do is whatever the first element of the coordinate and first element of the second coordinate, both you will add. Here also similarly LA1 plus MA2. Next LB1 plus MB2. Okay. Now it is in the form of, this is T. T of this whole thing is A. This whole thing is B. Okay. T of A comma B. Now how T of A comma B is defined like this. Given question is there, no? T of A comma B. So this whole thing is A and this whole thing is B. That means T of A comma B. Now you have to write in the form of, wherever it is here. How? A comma A plus 2B comma 3A plus B. That means A. First A is what? L A1 plus M A2. This is A. Next A plus 2B. That means L A1 plus M A2 plus 2B. That is 2 into L B1 plus 2 into M B2. Okay, comma 3A plus B. 3A into 3 you multiply. 3LA1 plus 3MA2. 3A plus B. B means this one. That is LB1 plus MB2. Okay. So now here it is there, no, TLA plus MB. You have to convert this into whatever this result is there, that you have to convert it into T of L into A1 comma B1 plus M into A2 comma B2. Sorry, this one. Okay. This T into L of A plus MB should be equal to L into T of A plus M into T of B. Okay. So for this one, you take out first all the L terms at one side. Whatever the L terms are there, you take one side, and also after that take all the M terms. So then that you have to convert into L into T of A plus M into T of B. Okay. So if you take out all the L terms, whatever you will get here, LA1. This is the single term here. You are able to see here. Okay. This is the only single term here. That is LA1. From here, from this term only LA1 is there. From here, LA1 is there. 2L. One more L is there. No, 2LB1. That is LA1 plus 2LB1. Okay. From the third term, 3LA1 plus here one more LB1. Okay. These are the only L terms. Next, we'll go to the plus M terms. What are the M terms? MA2, MA2, and here, so I'll write above that one. That whole thing I am writing here. It is equals to LA1 comma LA1 plus 2LB1 comma 3LA1 plus LB1. Okay. Plus M. What is M? MA2 comma MA2 plus MA2. One more M is plus 2M B2. Next here plus 3MA2 plus MB2. Okay. From here, you take L common. What you'll get if you take out L common? A1, comma. Here if you take out L, it is A1 plus 2, B1. If you take here L common, it is 3, A1 plus B1. Okay. Plus, if you take here M common, that is you are taking outside, that is A2, comma A2 plus 2B2, comma 3A2 plus here B2. Okay. So by seeing that, can you understand what it is? It is L into, this is instead of A, what is first starting P of A comma B, we defined A plus 2B, 3A plus B. That means this is A1, A1 plus 2B1 plus 3A1 plus B1. Next, plus M into, again A1, that is A plus 2B, 3A plus B. Okay. So that means this is L of T of A1 comma B1 and this is plus M of T of A2 comma B2. Okay. It is equals to L of this one A plus 2B, 3A plus TB. What is T? It is T of A1 comma B1 plus M into T of, this is A2 comma B2. Now L into, what is A1 and B1? Starting we have defined A1 and B1 is equals to A. That means this is T of A plus M into T of A2 B2 is B. So which is equals to LHS, no? Sorry, which it is equals to whatever starting it is there, no? So it is equals to what we have. This is T of LA plus MB. So T of LA plus MB is equals to L into T of A plus M into T of B. So instead of in the question, if he is asking X comma Y or alpha comma beta means L into T of alpha plus M into T of beta or L into T of X plus M into T of Y. Okay. In some questions, they will give A comma B. In some questions, they will give X comma Y. And in some questions, they will give alpha comma beta. So for anything, just that whatever the terms are there, the terms may be different, but whatever the procedure is there, that is the same for solving the linear transformation. Okay. So first thing, you have to see how the given transformation is defined. So transformation is defined like this. And whatever the basis is given in the question, that basis is from R2 to R3. So for check whether the given transformation is in this form or not. Here 2 terms are there, here 3 terms are there. Okay. So after that, you take the second formula of the linear transformation, that is T into L of, that is LA plus MB should be equals to. It is similar as, don't get confused here. that is similar as A into alpha plus B into beta. Okay. So instead of here A and B, we are taking L and M. Why? Because in the question it is already given as A and B. Okay. So if A and B are given, you take those two terms itself, and other two terms you take other anything. PQ you can take, XY you can take, alpha beta you can take, anything you can take. Okay. And you have to show that this is equals to this one. Okay. So for that, you have to define the term A, whatever given in the question, that is transformation A and B as these two terms. Why we are defining this one? Because this is in the form of R2. Okay. So A comma B are defined as A equals to A1 comma B1, B equals to A2 comma B2. Okay. In the question, if alpha is given, then you define it as alpha 1 comma beta 1. Okay. Here alpha 2 comma beta 2. This beta equals. Okay. If in the question x is given, then you define it as x1 comma y1 and y as x2 comma y2. Okay. Procedure is same. Just instead of these, if you have those terms, then you have to take just x1 and y1 of them. That is one x1 y1 or alpha 1 beta 1 or a1 b1. Okay. So after defining a and b, so substitute in the formula. This is our formula, no second formula. So L into A plus M into B. Instead of A, we are writing A1 and B1. And here instead of B, A2 and B2. So here, first you multiply. This is again scalar multiplication. Okay. That is A into U. F of A into U, no? So that scalar multiplication. This is scalar into these vectors. You are multiplying them. Okay. When you multiply them, you will write like this. L into A1 comma L into B1 plus M into A2 comma M into B2. Okay. So just take the terms here. A1 and A2 terms here. That is, when you add two vectors, we add the first coordinates. This first coordinate and this first coordinate. So we'll get LA1 plus MA2. Next LB1 plus MB2. Okay. So now we got this, whatever the transformation is there in the form of T of, you take here instead. Before the comma, whatever the term is there, that as A. And after that, you take the term as B. Okay. Now this is defined as, in the given question, how it is defined. Here it is there. In any question, in some other way it is there, means same, similarly, you have to convert that one. Okay. So T of this whole thing is A and this whole thing is B. So T of A comma B. Here, it is defined as A comma A plus 2B, 3A plus B. Our A is this one, B is this one. So LA1 plus MA2, A plus 2B, A plus 2B. Next 3A plus B. Okay. So 3A plus B. What you have to do, you have to take all the like terms at a side. So first like term is you are taking L common. So L from this one term, this is LA1. Next term LA1. Here two terms are there. So LA1 plus 2 LB1. Next in this is 3 LA1 plus LB1. Next one you take M terms common. So whenever you don't write this again, two steps you will have the same. Okay, this one only I have written above. So first take the L terms common from this one. Okay. Next take M terms. So after taking that, you take out the L outside. Okay, when you take out the L outside as a common term, you will get A1 plus 2B1, next 3A1 plus B1. And when you take out M common, you will get A2 comma this and this. So these, whatever these two terms are there, they are in the form of again T of A comma B. But instead of A comma B, you have A1 and B1 and here A2 comma B2. So from starting, we have defined A as A1 and B1 and B as A2 as B2. So T of A plus T of B. It is equals to RHS is equals to LHS we have got. Okay. So like this, you have to do the definition. By using the definition of linear transformation, you have to solve the given problem. So this is the 5 marks question you will have. So one more, this is from the second definition we have solved the problem, no? With the help of the first definition, how you'll solve the problem, we'll see one. Okay, here the transformation, the function is defined as like this. H is there. H from R2 to R2. Okay, defined by, so it is defined as H here x comma y is there. Y is equals to sin x comma cos y. Is H a linear transformation? Okay, this is the question we have. So for the solution, so first formula what we have, f of u plus v is equals to f of u plus f of v. Okay, this is the first definition of the linear transformation. And second definition is a into f of u is equals to, sorry. Okay, this is the second one. So with the help of this, so first one, if you are not getting, both are not equal, then it is not a linear transformation. No need of going into second one. If you are getting this as same, then you can go to the second one. Okay. So now h comma y is defined as sin x comma cos y. Okay. Here for these x and y values, for solving with the help of the first definition, you have to take here sin and cos are there. Those are the trigonometric functions. So for the trigonometric function, we can take the angles here. Okay. So if you take the angles, with the help of that, you have to solve this problem. So here we are choosing the angles as pi by 3, comma pi by 4, comma pi by 6, comma pi by 4. Okay, here two terms are there, two terms are there. So it is satisfying the basis of R2. Belongs to R2. And here, so substitute these values here in the given definition. So h of pi by 3, comma pi by 4. How it is defined? Sin pi by 3, comma cos pi by 4. So sin pi by 3 means sin 60 degrees. 180 divided by 3, no? So sin 60 is root 3 by 2, comma sin cos 45 is 1 by root 2. Okay. Next, h of these values. Pi by 6, comma pi by 4. So it is equals to sin pi by 6, comma cos pi by 4. So means this is sin 30 degrees. 180 by 6, no? It is 30 degrees. So sin 30 is 1 by 2, comma, and cos is same. So 1 by root 2. So we got these two values. These two values are for this one. F of, this is u and this is v. Okay. So now we will find the values here. F of u plus v. H of, so it is similar as h of this plus this one. That means pi by 3, comma pi by 4 plus b is pi by 6, comma pi by 4. Okay. Now we will get, this is in the form of a comma b and here c comma d. So what you'll get? A plus c, b plus d. So similarly, h of pi by 3 plus pi by 6, pi by 6, comma, put the comma here. Next, second one, pi by 4 plus pi by 4. So is equals to h of, this is 6 if you'll take as a denominator, 2 pi plus pi means 3 pi by 6. It is 2 pi by 4. So 2 times, this is also 2 times. So it is equals to h of pi by 2 comma pi by 2. H of pi by 2 comma pi by 2. Okay. So this is in the form of, again, what is given in the question? H of x comma y is equals to, this is h of x comma y. How it is defined? It is defined as sine pi by 2 comma cos pi by 2. So sine pi by 2 is 1 and cos 90 is 0. Okay. So this is f of f, u plus v. Here this is u and this is v. So you are adding these two terms. So you get comma pi by 4 plus pi by 4. So again it is in the form of h of x comma y. So x comma y means sin x comma cos y 1 comma 0. Okay. So now it should be, this should be equal to what? F of u plus f of v. That means here f of means instead of f we have h. H of u plus h of v. What is u here? This is u. This whole thing is u. This whole thing is v. Okay. So now next f of u plus f of v is equals to h of, what is this one? This is pi by 3 plus pi by 4 plus h of pi by 6 comma pi by 4. Okay. So now we got these values. Now from here, this is the value of this one and this is the value of this one. Directly if you substitute here, you will get root 3 by 2, 1 by root 2 plus, you are unable to see, no? So it is equals to root 3 by 2 comma 1 by root 2 plus 1 by 2 comma 1 by root 2. Okay. So here also first points of the coordinate you have to add, that is root 3 by 2 plus 1 by 2 comma 1 by root 2 plus 1 by root 2. Okay. So if you add that, you will get it as root 3 by 2 plus 1 by 2 comma 1 by root 2 plus 1 by root 2. So it is equals to root 3 plus 1 by 2 comma, this root 2 plus 1 by root 2 means 2 by root 2. So you can write it as root 3 plus 1 by 2 comma, this 2 you can write it as root 2 into root 2. So this denominator both will get cancelled, you will get it as root 2. Okay. So we got this value as root 3 plus 1 by 2 comma root 2. But what we got this value as 1 comma 0. So both are not equal. So first condition only not satisfied. Therefore, it is not a linear transformation. Okay. So here, therefore, we can write, therefore, h of pi by 3 plus pi by 6 comma okay. This one pi by 3 comma pi by 4 plus pi by 6 comma pi by 4 is not equals to, which one? This one. H of pi by 3 comma pi by 4 plus h of pi by 6 comma pi by 4. Therefore, H is not a linear transformation. Okay, like this, you have to solve the problems of linear transformation. So with the help of the first definition, or with the help of the second definition, you can solve the problem. Okay. So this is the main thing. First definition means f of u plus v is equals to h into, you take any angles here. Okay. Do not take the infinity of 1, 0 or 1, what we have. 30 means 1 by 2, 45 means 1 by root 2, 60 means root 3 by 2, and 90 means 1. Just reverse of that one, you will get the cos values. So if you take those terms and if you solve this one, then you can solve this problem given in your textbook, this one. Okay. So this is about the linear transformation. So you have to show like this. If both are equal, then it is a linear transformation. If both are not equal, this value we got 1 comma 0. This value is this one. Root 3 plus 1 by 2 comma root 2. Okay. So this is about the unit 4, about the linear transformation. In this only, next we have the definitions of what is curl of a linear transformation. So I have told on the day, that is a rank nullity theorem is there. Okay. So in the definition of null space, or we call it as kernel. Okay. Kernel of T or null space, both are same. It is defined as, we'll write it as n of T or curl of T. Okay. In shortcut, this is written as capital N of T, and curl of T is defined as KER T. Okay. So this is defined as X such that these two, whatever semicolon is there, that we call it as X such that X belongs to V, T of X equals to 0 bar. This is the identity element. 0, whatever dash is there, 0 dash is it is the additive identity element. Okay. This is defined as a null space or kernel of T. Okay, this you have to remember. For solving the problems or for solving the theorem, this notation is used. This is about the null space or kernel of T. Next one is range space of T. Range space of linear transformation, or range space of T. It is denoted as R of T, capital R of T. Okay. So it is defined as T of V such that V belongs to capital V. Okay. T of V such that V belongs to V. So this whatever V is there, this is one of the vector of capital V. Okay. So vector space set you will have, no, from that you are taking one element which is known as small v. So which that means T of V, whatever the elements are there in the range set. Just now we have seen, no, domain and codomain. So whatever the elements are there which are having the mapping, those elements are called as a range space of linear transformation. Okay. This R of T and N of T, this is a null space, this is R kernel of T, and this is a range of space, that is R of T. Okay. So next is rank of T. So rank of T, it is denoted as row. We know rank is denoted as row. So row of T, and it is what we call the rank of T means it is the dimension of range space of T. It is the dimension of range space of T. Here only you take T. Okay. Rank of T is dimension of range space of T. So in range space, whatever the range set is there, in that how many elements are there, that is called as a rank of T. If you think here in this set, if you have 3 elements, so then rank of the T is 3. Okay. In this, if we have 2 elements, then the rank of T is 2. Okay. Next, we have nullity of T. So nullity of T means nullity of T is denoted as nu. Like this it is. Yes. Nu of T. Okay. Nu of T is just like as V you will have. Okay. This is called as nu. Nu. Okay. Nu of T is denoted for the nullity of T, and it is defined as dimension of null space. That means here whatever the elements are there in the null space, that is called as nullity. How many elements are in the range space, those are called as rank of T. Okay, these definitions are important for solving the theorems and also for solving the problems. Okay, so these 4 are important definitions for the, you have the rank and nullity theorem is there, which is the 10 marks question, which is the important one. You have in unit 5 unit, 5th unit, you have that one. Okay. So next week we'll see the other topics regarding of the block 2 and also block 3.